Hello from Germany. This is my first try of a disassembly of a notebook battery pack. This pack is really common. It's used in various notebook types: Sanyo, Toshiba, Medion and others. They take this same type and use other descriptions of the battery pack, but it's very common. So for this type I've done some teardowns. I already have done some teardowns, and for this I have some practice in this type, so some steps of a teardown will be really fast. For the first, we get a secondary cover that we have to remove. There is a slight indent where you can get open with a screwdriver. The shield, where it comes out. The battery could be used without the shield, but they have done a shield to apply some ripples to pull it, to have a better pull on the battery. Goes off. Okay, next step is to remove the label, and be careful with sharp metal tools, because you can break into the lithium cells and that won't be fine. Okay, got it. And for this type, the label seals an opening where we know how the cells are placed. For that, we can the force, the needed force in the right directions, and don't harm the batteries, the cell casing for itself. Goes away. Got it. Got a really big box of rests. Okay. Next step is to cut off this plastic indent inlay. You see, you can do force on the plastic without doing force to the cells. Break off the bridges, wiggle it out, off it goes, and now we have the contacts of the cells lying open, so we can do a short measurement. Of the overall voltage. The positive end, as marked here, is always the indent you have at the end. because the cap of that cells has to be isolated from the tube which it's placed in. This is an all metal tube, heat shrunk with a plastic cover that covers the metal that goes up from the negative pole right beneath the plus pole, and from there it is only a short distance, so take care that you don't remove this isolation from separating the minus and the plus. Okay, the lower end, and these batteries are put in series, is down here, so we can just take in there, and here I see the metal bonding between the contacts, and take this and see we have a fair amount of charge in it. 3.6 times 3 equals 10.8, so this cell is fairly loaded. You have to take care about our disassembly. Okay, now I know that this is the battery protection circuit board in there, as there are the contacts, and the wiring to the protection board will be from the protection board to the cells. It will be in here, so I won't cut on this side because maybe I cut wiring, and if I will cut the isolation of the wiring, this may cause shortcuts to other parts of the battery pack, and takes a discharging process which will be horrifying. Okay, so I cut these edges alongside the cells. Okay, that will do. Risky angling. Okay, then comes in the wooden wedges. As they have more flexibility than the metal tools, they won't harm the metal container of the cells. You can take these drying clamps, put that off, put the spring out, and then you have a lot of cheap wedges that you always can replace by new clamps. The plastic ones aren't that suitable, as they readily break when done in force. And this one comes out really fast. So that I have an easy way to break out this plastic without doing any leverage to the cells itself. Okay, some tricky. Got it. Off it goes. Some glue in the lever art first. These are the glue spots. You maybe see here. And having the pack of the connecting wires, stretching them, you can start to disconnect these contacts with the snips. Okay, keep in mind this may shortcut, will no longer shortcut itself with something else as it's the far end. Same with here. Here's the Hilomane stripe that connects the packs. To have each disconnected, just turn the snips. Next connect off, and then we are almost done. I'm going to do this very short. And we are off with the electronics. Okay. Now we have here some adhesive between the cell layers and the pack layers, or pack series. And my goal in having these cells is to keep them in these two packs, because then you have a 2000 milliamp hour cell and another 2000 milliamp hour cell already in parallel, bonded by a good connection, and we have a 4000 milliamp pack. Okay, let it wait. Next. Adhesive will come up really good. Same procedure as last time. Get it into grip and then turn it up. Be careful, they keep them apart. Okay, cleaning up the pack. You have to move the adhesive. Be careful, these edges are really sharp and easily can cut into your skin. So undo the adhesive strip. Cut short the metal contacting strip. Same to the other side. Flatten them out. Other side. Oh, it goes. Separate trash. Remove tape, ping. Okay, this flat. Isolation looks good. Get the adhesives off. And even for that, woolen wedge is even more suitable. Okay. First cell pack. And this is my 11th one. Stopped recording. Next one. Next part. Recording. We've done an inventory mark. We've checked the voltage. It's fine with 3.6. Beyond 3 volts. So anytime fine. And I can get it. To my power bank or battery loader. Plus up. It still shows a fair amount of 50%. You can start loading it to full. This will run. Okay, get some rubbish off the table. Get the next pack. This may be suitable. Remove some adhesive. Okay, this one flattened out. Fairly good. Some transparent tape on it. Easier. Okay. Electronic sports. Fine. Edges down. Okay. Okay. Second pack will be the same voltage, almost the same. Same. Do the inventory. Number 3 and 4. The same problems to remove. Fairly good. Bulky adhesive. Fine. Okay, flatten that out. This is the same color. inventory. .5 and 6. Clean up. And we're done with the pack. For measuring the capacity of the remaining capacity of these cell packs, we're doing another process, and then when these are fully loaded, they're deloaded with a unloaded with a discharged with a capacity controller, and then we'll know how much capacity is left on these separate packs. Thank you.